Now let us move to the next question, that is question number 33. A sample of 0.1 gram of water at 100 degrees Celsius and normal pressure requires 54 calories of heat energy to convert to steam at 100 degrees Celsius. If the volume of the steam produced is 167.1 cc, the change in internal energy of the sample is how much? Okay, again, this is a question where it came from the chapter thermodynamics and you have to apply first law of thermodynamics. First law of thermodynamics is known to you, I guess, if you have studied what you know. As you know, delta Q is equals to delta U plus P delta V. This is the first law of thermodynamics. So let me write it down once for you. Delta Q is equals to delta U plus P delta V. You need to calculate the internal energy. P is supplied to you, change in volume is supplied to you, delta Q is supplied to you. I hope this question would be easy for you to solve. If you solve this one, your final answer would come out to be 208.7 joule. So option number 3 will be the correct answer. Please check on this using this formula, right? So let us go to the next question, that is question number 34. The momenta of the force F equals to 4I cap plus 5J cap minus 6K cap at 2, 0, minus 3 about the point 2 minus 2 minus 2 is given by. 2 points are given. We need to calculate the torque. So how you are going to do with the two position? So what you have to do is, you take the positions. This is suppose one point position vector r naught. This is another position vector r. Okay. Now you have to calculate torque, means the force will be in this direction. Suppose this is rotating in this direction. So this is my force F. So torque is equals to r minus r naught multiplied with what? Torque. This will be your perpendicular distance. This is the perpendicular distance, right? What is the formula of the torque? Torque is nothing but perpendicular distance multiplied with the magnitude of force. Now you need to calculate force, or force is given in the question. Yes, it is given in the question. Okay. Now you need to just calculate this position vector. How you are going to do? R minus r naught, that will give you the value. Later on, this is a cross product, right? So you have to take what? Determinant form and find the answer. So your final answer would come out to be number 4, that is minus 7I cap minus 4J cap minus 8K cap. This one will be your correct answer. So option 4. Let us move to the next question, that is question number 35. Question number 35, it says that a student measured the diameter of a small steel ball using a screw gauge, right, of least count 0.001 centimeter. This is a question from class 11 from the measurement chapter. The main scale reading is 5 millimeter and 0 of circular scale division coincide with 25th division above the reference level. So circular scale reading is there, main scale reading is also there, least count is also given to you. If the screw gauge has a 0 error of minus 0.004 centimeter, the correct diameter of the ball is. How you are going to check the diameter? What you will do? Diameter of the ball will be equal to main scale reading MSR plus circular scale reading multiplied with the least count minus 0 error. Please look at it very nicely. This is the formula you will be using. Put all the values, the diameter of the ball will come out. And screw gauge is the only device, and vernier caliper, those are the device, not only, those are the device which can measure the diameter of a circular object. So with the help of this one, you can find out the diameter. I hope this question is clear to you. Let us move now to the next question, that is question number 36. Question number 36. A block of mass M is inclined on a smooth inclined edge ABC of inclination theta as shown in the figure. The wedge is given an acceleration A towards the right. The relation between A and theta for a block to remain stationary on the wedge is. Okay. This question is from the chapter I can say laws of motion, where you will be using the component of forces. If you have remember non-inertial frame, where pseudo force is applied, with the help of that also we can find out. Let us see how to solve this one first. This is the block which is this is the inclination theta, and the block is resting here. This will be its normal, right, normal n. So it's this will be its mg, this will be n sin theta, this will be n cos theta, this is angle theta. If this is theta, this one will also be theta, and this one will be ma, that is your pseudo force, right. It's in non-inertial frame, non-inertial frame, right. So this is the block diagram, and where all the components are given. Now question it is asking at what condition this block will not move. This block will not move when n sin theta is equals to ma, equation 1, and n cos theta is equal to mg, equation 2. On the either side it will not move, nor it will move upward or downward if this is the condition arrives. So if I take the ratio of 1 and 2, you will get tan theta will be equal to a by g. So your a is coming out to be g tan of theta. So this is all, this is the acceleration value, we got it. So you see in the option which one will be the correct answer. If you see option number 4, a equals to g tan of theta. So option number 4 I can click on it. This is the correct answer. Now let us move to the next question, that is question number 37. A toy car with charge q moves on a frictionless horizontal plane surface under the influence of a uniform electric field E. Due to the force QE, its velocity increases from 0 to 6 meter per second in 1 second duration. At that instant, the direction of the field is reversed. The car continues to move for 2 more seconds under the influence of the field. The average velocity and the average speed of the toy car between 0 to 3 seconds are respectively. It seems like the question is from the chapter electrostatics, like under the influence of electric field it is moving. But if you see, if you apply the concept out here, it will be from the chapter equation of motion. You are going to use a formula for different velocity, that is s equal to ut plus half a t square. The acceleration is going to change, right. So if you use this formula, the answer is will be coming out to be 1 meter per second and 3 meter per second. Let me tell you the answer so that you can try it by yourself. So please use the formula s equal to ut plus half a t square and find out the different displacement, that is s1, s2 and s3. Then you can find the total displacement, and from there you can find out the average velocity, right. Total displacement divided by total time taken. So finally your answer from this one will be number 3. Now let us move to the next question, that is question number 38. A moving block having mass m collides with stationary block having mass 4m. The lighter block comes to rest after the collision. When the initial velocity of the lighter block is v, what the value, then the value of coefficient of restitution will be how much? Okay, my dear students, if you see this question, this is from the chapter work, power and energy, that is elastic collision and inelastic collision in 1 and 2 dimension. From that topic it came. So you need to know what is coefficient of restitution out here. Okay, let me tell you at the beginning only. The answer of this one is 0.25. How it will come? Just use this formula. E is your coefficient of restitution, is equal to velocity of separation divided by velocity of approach. So with the help of this one you can find out, and we know we can use the previous concept that the momentum remain conserved. If you use this concept and the kinetic energy remains conserved, the kinetic part is not read from there only, momentum part only we can find out the velocity of separation and velocity of approach. So your answer will be 0.25. Now let us move to the next question, that is question number 39. A body initially at rest and sliding along a frictionless track from a height h as shown in the figure just completes a vertical circle of diameter AB equals to d. The height h is equal to, you need to calculate the height h. So my dear students, here we have to use the concept of law of conservation of energy, where total mechanical energy in the beginning will be equal to the total mechanical energy afterwards also at the end. So initially your kinetic energy will be 0, the total mechanical energy will be mgh, and at the last your potential energy, that is mgh, will be 0, but kinetic energy will be there, right? So what I am trying to say you is that you are going to use total mechanical energy at the beginning will be equal to the total mechanical energy afterwards. When the ball was here initially, as well as this will be the addition of kinetic energy plus potential energy, find it out, and here also it will be the addition of kinetic energy plus potential energy. So my dear students, just equate these two and you will find out the height of this one. Your answer will come out to be 5/4 d. Let us move to the next question, that is question number 40. Three objects, A, that is a solid sphere, B, a thin circular disc, and C, a circular ring, each having same mass m and radius r, they will spin with the same angular speed omega about their own symmetry axis. The amount of work required to bring them to rest would satisfy the relationship. That is the work done you have to calculate here. What we know, work done is nothing but the change in kinetic energy. In case of this one, this question actually came from the chapter System of Rotational Bodies, that is the Center of Gravity chapter from class 11. So what you have to do, you have to take the ratio of the work done. So work done is nothing but your energy, which is equals to half I omega square. So work done is directly proportional to I. I hope you remember the formula. So if you take the ratio of WA by WB to WB by WC, then your answer is going to come out to be WC greater than WB greater than WA. So option number 1 will be the correct answer. So let me click on option number 1. So this is my correct answer. Now let us move to the next question, that is question number 41. Which of the following statement is incorrect? So number 1, rolling friction is smaller than sliding friction. It is true. Number 2, frictional force opposes the relative motion. This is also the basic definition of friction. Number 3, limiting value of static friction is directly proportional to the normal reaction. Absolutely correct. Coefficient of sliding friction has dimensions of length. So option 4 will be the correct answer for the incorrect one. What I am trying to tell you is that any coefficient of friction has got no units, right? It is coefficient of friction is given by F by N. So their dimension or the unit cancel out. They are dimensionless. So number 4 is the correct answer, right? Let us move to the next question, that is question number 42. Question number 42 says a solid sphere is in rolling motion. In rolling motion, a body possesses translational kinetic energy, that is kT, which is equals to half mv square, as well as rotational kinetic energy, that is kr, that is half I omega square. Simultaneously, the ratio of kT by kT plus kr of the sphere is. So you have to see this one. You have to use this formula. We know kT is equals to half mv square and kT plus kr, that is rotational kinetic energy, half mv square plus half I omegas square, right? Just take the ratio of kt and kt plus kr. You'll see that the right option is coming out to be 5:7, that is option number 3. If I go back to the question, option 3 will be my correct answer, so I can click on option number 3. Now let us move to the next question, that is question number 43. Question number 43 says that a solid sphere is rotating freely about its symmetry axis in free space. The radius of the sphere is increasing, keeping its mass same. Which of the following physical quantities will remain constant for the sphere? Okay, now what do you think, which one will be constant? If a body is rotating freely, that means its net torque would be how much? Net torque will be equals to 0, or I can say there is a relation between torque and angular momentum, dl by dt is equals to 0, which is going to prove that ddt of constant is equals to 0, right? So this is from the chapter rotational bodies of class 11. So L is remaining constant. L is the angular momentum. Which one will be the correct answer? Option number 4 will be the correct answer. So I will click on option number 4. Now let us move to the next question, that is question number 44. If the mass of the sun were 10 times smaller and the universal gravitational constant were 10 times larger in magnitude, which of the following is not correct? Raindrop will fall faster. It will fall faster because what? The mass has been reduced and acceleration due to gravity were 10 times larger. That means your g will be equals to 10 times of g. Okay. Number 2, time period of the symbol pendulum of the earth would decrease. This is also correct. Walking on ground would become more difficult. Correct. G on the earth will not change. Acceleration due to gravity will have to change because there is a variation of the what? Universal gravitational constant. So small g, that is acceleration due to gravity on the earth, will not change, is the wrong option. So number 4 is the correct answer for this. This is from the chapter gravitation of class 11. Now let us move to the next question of this question paper, which is the last question, question number 45. Question number 45. The kinetic energies of the planet in an elliptical orbit about the sun at positions A, B and C are Ka, Kb and Kc respectively. AC is the major axis and SB is perpendicular to AC at the position of the sun as shown in the figure. Then if you see the question, it is from the chapter gravitation of class 11 and it is from the topic Kepler's planetary law. Okay, where sun is kept at one of the foci. So this is, suppose A, here the velocity is, if I take out the pen, let us consider the velocity out here is VA, this one's velocity when the planet was here VB, and at position C it is VC. Now if you can see the diagram, the one which is closer to the sun is VA and VB, that these 2 points. So VA will have the maximum velocity, and then we'll have VB, and then at last we'll have VC. So if velocity VA is more, then kinetic energy A will be more, then kinetic energy at B will be more than kinetic energy at C. If you see the option number 3 will be the correct answer. Ka greater than Kb greater than Kc. So I can write this one. This is the end of the question paper 2018, where all the 45 questions, answers and few of them solution are also given to you. And for what which I am telling you to apply the formula and do it, kindly do it. It will help you to revise the previous chapters also of physics class 11 and 12.